What in the world is happening? Okay. Just be quiet. Okay, so 11.6, page 150. Look at the top. It says, Miss Myers pours an equal amount of milk in each of 6 cups. If she pours all the milk, how can you determine what fraction of a gallon is each cup? So she's taking milk and dividing it into 6 cups. What's the total amount of milk she has? We're on page 150. Huh? Look at the top of page 150. It says Mrs. Myers pours an equal amount of milk into each of 6 cups. So she has, we want to know the total amount of milk that she's splitting in between 6 cups. Half. Yes, the total amount milk she has is half a gallon. She's dividing that half gallon into 6 cups. So she's pouring it, dividing it equally into 6 cups. So the question is, what fraction of a gallon is in each cup? First thing, we put this over 1, right? Same thing. Keep the first number the same. Change the sign. And flip this. So instead of 6 over 1, it's going to be what?
6 over 6? 1 over 6.
1 over 6. So keep, change the sign, flip the numbers. And then you do the same thing. 1 times 1 is?
1.
And 2 times 6 is?
12.
So she would have a 1/12 a gallon in each cup. Huh? Huh?
Can it be 12 too?
No, it can't be 12/2 because it's 1 over 12. This is 6 over 1. So any number over 1 is that number. So it's over 1. So that's why 6 over 1 can be 6. This is 1 over 12. You can't change that to just 12 because that's 2 different things.
Wait, so if we have like a text like McGraw and it says like get the answer and it's like just like whole numbers like the answer you have to put the 6.
If it is 6, if the answer comes out to something over 1, that's the same thing as saying 6. Just like we took 10, right? 10 is a whole number. We put it over 1 to make a fraction. Clea, get off your computer, close it. Nobody's computer should be open. We turn this whole number into a fraction by putting it over 1. This is a fraction. You can't put it over. It's a fraction. You can't change that. It's 1 is the numerator. If 1 is the denominator, then that's the same thing as saying a whole number. So the difference between lesson 11.4 and 11.6 is lesson 11.4, we're dividing a whole number divided by a fraction. Here, we're taking a fraction of something and dividing it by a whole number. It's the only difference. Same steps, same keep, change, and flip. But this one, you have a whole amount of something and you're dividing it into a fraction. This one, you have a fraction and you're dividing it into a whole number. It's the only difference. Turn to page 151. Okay, we're going to do 2. Look at number 9. It says a garden has an area of 1/10 of an acre. What fraction of an acre is each of the 4 sections? So they're starting with how much of a garden?
1/10.
They have 1/10 of an acre. And they divided it into how many sections?
4.
And they want to know how many acres are in each section. So we have 1/10 divided by 4. We have to make that a fraction. 1/10 divided by, we have to put that whole number over 1 to make it a fraction. Now what do we do with the first number? Keep it the same. And then what? Change division to multiplication. And what do we do here?
1/4.
Flip it to 1/4. So 1 times 1 is what?
1.
And 10 times 4 is?
40.
So your answer would be 1/40th of an acre. Those are two different things. 1/40th is different than 40. That's like saying if I have a fourth of a dollar. If I have a fourth of a dollar, how much is that? It's 25 cents. If I have 1/4, 2/4 would be 50. A dollar is made out of 4 quarters, yes? So if I have a fourth of a dollar, that's only 1/4. If I have 2/4, how much would that be? 50 cents. If I have 3/4, what would that be? And if I have 4/4, that would be what? So if I say, is 1/4 of a dollar the same as $4? If I were to write 1/4, is that the same as writing 4? Or is that the same as writing 4/1? No, 1/4 is like saying 25 cents. 4 is like saying $4, and 4/1 is the same thing as saying $4. Because if I took 4 and divide it by 1, it gives me 4. These two are the same. These are whole numbers. This is a fraction. You can't change that.
Oh, so if the one is at the bottom, that means
It's a whole number. The one is if the 1 is the denominator, then you can just make it into a whole number. But if the 1 is the numerator, you can't change that. That's just a part of something. This is a whole of something. Okay, we'll do one more. I want you to look at number 11, and I want you to try that one on your own. Try it on your own, and then I will do it with you. Raise your hand if you're not done. Okay, good. So we have, it says Theo cuts this board into 4 equal sections. What is the length of each section? So what is the total amount I'm starting with?
1, 4.
What is he cutting? Huh?
Just cutting 1, 4.
What is he cutting? What is he cutting? The board. How long is the board?
1, 4.
So the total amount he's starting with is 1/4. And he's dividing it into what?
4.
4 equal sections. So we need to make this a fraction. 1/4 divided by 4/1. Now we need, since we're dividing by fractions, we need to do our rule. Keep, change, flip. Now we can solve. 1 times 1 is what? 4 times 4 is what? So each section is 1/16 of a foot. How many of you got that right? Good job. Okay, the last section we're going to do is, quiet. Go sit down. Hush. So the last part is solve problems involving fractions. These are where those word problems come into play, and you have to be pay close attention to what you're talking about. So it says at the top of 156, it says Elizabeth uses all of the ribbon to decorate 6 boxes so that 4 of the faces of the box have the same amount of ribbon. How long will the ribbon on each face be? It says, so basically this is a 2-step problem. First of all, it says she uses all the ribbon to decorate 6 boxes. So she has, what's the total amount of ribbon she has? What's the total amount of ribbon she has? The total amount of ribbon she has is 3 feet. When you're dividing, you start with the total amount. What is it that we're splitting up? We're splitting up 3 feet of ribbon. 3 feet of ribbon. And we're splitting it between what? 6 boxes. So she has 3 feet of ribbon, and she's dividing it between 6 boxes. So that's like saying, if I would say, so I could write this as a fraction, 3 divided by 6. Remember, this is how you would read a fraction, 3 divided by 6, yes? And I can go even better and simplify it. What number can go into both of these? 2 can go into 3? 3 can go into both of these. Three can go in here once. So each box is going to have half a foot of ribbon. So each of these, she has 3 feet of ribbon, each divided by 6 boxes. So each of the 6 boxes will have half a foot of ribbon for, oops. I'm just writing this so you can you know. Okay. So that's the first part. She'll use half a foot of ribbon on each box. Then it says, Elizabeth uses all the ribbon to decorate 6 boxes so that 4 of the faces of the boxes have the same amount of ribbon. So a box has how many faces? Think about a box.
4, 4, 5, 8.
Think about a box. It has 6. I don't have a box. Wait, we can say this box. Here you go. It has 1, 2, right? Here's 2. Then I have 1 by me. That's 3, 4, 5, 6. So how many faces does it have? 6. She only wants to put ribbon on how many of the faces?
3.
How about we look and quit yelling out numbers? Look at the problem. Stop yelling out numbers. Don't anybody answer. I'm going to read the problem. You look at the problem, and I want you to tell me how many faces, after when I ask, I want you to tell me how many faces she wants to have ribbon on. It says, Elizabeth uses all of the ribbon to decorate 6 boxes so that 4 of the faces of the boxes have the same amount of ribbon. How many of the faces does she want to have ribbon on? 4. She doesn't want to have the ribbon on all of them, just 4 of them. So, how much ribbon is for each box? How much ribbon is she going to use on each of the boxes? What's the total amount for each box? That's how many faces she wants to cover. But how much ribbon does she have to use for each box? She has half a foot of ribbon that she can use for each box. So if she has half a foot of ribbon and she wants to take that ribbon and divide it by what? How many faces does she want to cover? 4. So first of all, we found out how much ribbon was for each box. So if she wanted to cover each box, she would have a half a foot of ribbon for each box. But she doesn't want to cover all the faces in the box. She only wants ribbon on 4 sides of the box, not 6. So we take that half a ribbon and we're going to divide it by 4. So that's half divided by 4 over 1. Same rule applies. Keep, change, and flip. 1 times 1 is what? We don't know what 1 times 1 is?
1.
And 2 times 4 is what?
8.
So on her boxes, the 4 sides that she wants to have ribbon on, each side will have an 1/8 a foot of ribbon. These are harder. Okay, look down at the next one, at the bottom of the page. It says Martha has 5 muffins. To how many friends can she give a fourth of a muffin to? So what is Martha starting with? What does she have a total amount of? 1/4 what? What's the total? What is she wanting? What does she have that she wants to split up? What? Yeah, yes, 5 muffins. She has 5 muffins. That's what she wants to split up, yes? So that's what we're going to write first. She has 5 muffins. Like I said, you have to ask yourself, what is the thing we're splitting up? The thing she wants to split are her muffins. She has 5 of them. So that's what goes first. Some of y'all need to pay attention because y'all pay attention to the wrong things. She wants to divide those muffins how? Into 1/4, yes. So we rewrite it. 5/1 divided by 1/4. Keep this the same. Change the sign and flip. So what would my answer be? Or what? So if she gave each friend a fourth of a muffin, she can give 20 friends a piece of the muffin. We're going to do a couple more of these. Okay, I need you to listen carefully, okay? Because I'm going to read these. It says, Dwayne completely covers 1/3 of a bulletin board with 6 pictures. Each picture is the same size. What part of the entire bulletin board does each picture cover? So what is Dwayne starting with? It says Dwayne completely covers 1/3 of a bulletin board with 6 pictures. What is he starting with?
Say it again.
Look at that bulletin board. Let's say I want to cover 1/3 of that bulletin board with 6 pictures. So what is the amount I'm starting with? 1/3. I'm starting with 1/3 of a bulletin board. That's all I have to cover. And I'm dividing it between what? 6 pictures. And I'm just going to go ahead and put it over 1. So I started with 1/3 of a bulletin board, and I'm dividing it between 6 pictures. And the question is, what part of the entire bulletin board does each picture cover? So how much is each covering? Again, keep, change, flip. 1 times 1 is what? 3 times 6 is?
18.
So each picture will cover 1/18 of the bulletin board. We're going to do 2 more. One we're going to do on here and one we're going to do in your book. Okay, listen carefully. A deli has 12 pounds of turkey. The deli uses 1/4 a pound of turkey on each sandwich. How many sandwiches can be made So what is the deli starting with? 12 pounds of turkey. And they're dividing it between what? Yes. Each sandwich has a fourth. So how many sandwiches can they make? Keep, change, and flip. 12 times 4 is what? 1 times 1 is what? So this would be 48 over 1 or what? Okay, look at page 157. This is what you guys are going to do, but we're going to do number 1 together because it's kind of confusing. Page 157. Look at the top one, number 1. Okay, 157, it says Sonia is making muffins. The recipe uses half a cup of flour and makes 12 muffins. How many cups of flour should Sonia use to make 6 muffins? So she's making what? Huh? She's making muffins. It says that she would use a half a cup for 12, but she's only making 6, right? She's only making 6. So she's making half of that, right? She's splitting it in 2. Yes?
Yes.
Okay. So we have half a cup. She did 12 divided by 2 and got 6. So we're going to do half a cup and divide that by 2. Again, you would use half a cup for 12 muffins. We want to figure out how much she needs for 6 muffins. So we took 12, she took 12 and divided by 2 and got 6. So we're going to take the half a cup of flour she has and divide that by 2 to find out how much flour she just needs for 6 muffins. So I keep, change, and flip. 1 times 1 is 1. 2 times 2 is 4. So for 6 muffins, she would only need 1/4 a cup of flour. Yes? Because basically I knew that half of 12 is 6. I knew she divided 12 divided by 2 to get 6. Six is half of 2. So if I have 12 and I cut it in half, that's, if you cut something in half, you're dividing it by 2, right? If you cut something straight in half, that means you're dividing into 2 parts, right? So 12 divided by 2 is 6. So she halved the recipe, so I need to take half of what the flour she needed. So that's how I got a half a cup of flour, and I just divided it by 2. I cut it in half to find out how much she needed for that. Like I said, for dividing fractions, you have to read very carefully. If you don't, not too much. If you don't, you're going to get it wrong. If you write it in the wrong order, it's not like multiplication. With multiplication, if you're just multiplying fractions, you can switch them and still get the same answer. But if you write a division, if you're dividing fractions and you write it wrong, it's going to be wrong. Because just for example, if I had said, this is the right way, but let's say I said 2 divided by 1/2. I kept this the same. I changed the sign and I flipped this. My answer would be 4. Is that the same as this? No. So like I said, you have to be very careful, read very carefully when you're dividing fractions to make sure you know what is the thing I'm splitting up. That comes first. And then how am I splitting it? That comes second. You already did 1, so everybody should have 1 right. Okay, so do your exit ticket. Then you're going to do page 157, numbers 1 through 10. And then you'll do Alex quick tables. And then you'll do Prodigy.
Wait, what? Oh, yeah. Oh, never mind.
Where's my... Why don't I have my... What in the world? What's happening? Did you plug them up? Yeah. Okay, then it should be fine. If they're plugged up, you should be fine.